All right, everybody. Thanks for joining us tonight. We're excited to do our very first ever .NET user group meeting online. The circumstances notwithstanding are not good, but we look forward to seeing how this goes and maybe enhancing our events from here on out. So I'd like to start the evening by just introducing myself. My name is Matt Rui. In case you don't know me, I run the user group along with Brian Olson, who's probably behind my head right now. Um, uh, we're joined tonight by Andy Baer, who's going to walk us through event-driven architectures. But before we get into that, I wanted to let you know that this is an interactive session. You can participate by following the instructions in the YouTube video. Ask your questions in the on Slack or in the live stream, and we'll follow up with Andy to get you an answer. We also have our sponsor tonight is going to be giving away 4 $50 gift cards to participants in our Slack channel. If you want to be a part of that, go ahead and jump on over into the Slack channel. Again, there's a link in the YouTube video description. We'll be giving those out throughout the presentation, so keep an eye on the chat. We're not going to do those all at the end, so you got to kind of watch it. So as far as community announcements go, we usually start our meetings by talking about what's going on in the community, how things are going. It's a little bit more difficult to be interactive in this setting, so we'll be collecting those in the Slack channel. A few that I can think of off the top of my head, I know that Microsoft Build is coming up towards the end of May. They've canceled the in-person conference, but it will be a completely virtual event now, so that's kind of cool. So everybody gets to watch it as it goes. They do that every year anyway, but I assume that this year will be a little bit more focused on that. There's a lot of community groups who are moving their meetings virtual like we are. So you should keep an eye out for those. I know a few have already been mentioned in the Slack channel. So jump on over there again and see what those are. And then last one I have is Carl Franklin's Roadshow, which was scheduled to happen earlier this month on March 11th, got postponed, and I guess now it's been officially canceled, unfortunately. But he is going to do a virtual version of that. He's calling it the Desk Show, and I'll be sending out details regarding that. Probably in the Slack channel, I can do that during the meeting here, or just watch the email and you'll see it. Also, for tonight, we usually have our sponsors get up and say a few words. Tonight, they asked me to do that for them, so I'm going to read through what they asked me to say. And if you get a chance, really do take a minute to say thanks to Robin and Hallie and all the folks over at Advantage Tech. They've kind of weathered this storm with us, and we're really thankful for their participation. So Advantage Tech would like to tell you that during this very interesting time, they are here to support you. If you are thinking about making a job change, now is the time to be speaking to their recruiters and team. Spend the time now to build those relationships so that when the time is right, they can help you find a job with the right culture, the right technology, and career goals, so that when the right opportunity does open, they can reach out to you immediately. Many companies are putting positions on hold temporarily. However, the need is still there and the markets will open back up in full force soon. They would love the opportunity to speak with you as your schedule allows and look forward to building that relationship. I can't say enough that we really appreciate Advantage Tech and their support in this tough time. So without further ado, I'd like to introduce Andy, who's going to be our presenter for tonight. Actually, yeah. So Andy, let's do this. This is part of the challenge of streaming. I'm hoping this all works out. So we got Andy through Skype. He's in a different room. We got all sorts of stuff going on here and cherry rigged together. But I think it will hold, and hopefully it's working. And I appreciate your patience. But Andy, thanks for being a participant in our group tonight, and I'll give it over to you.
Great, thank you. And just to let everyone know, Brian and Matt are gonna kind of monitor the Slack feed. I'm not gonna try to monitor that while I'm doing the presentation. So if they don't ask your questions, it's on them, not on me. So just so you know that.
All right. Thanks, Andy.
All right. Yep. All right. So The topic Matt mentioned was event-driven architecture. I kind of went back and quite a bit on this one. Kind of when I decided how to present this, and rather than dive into a very platform-specific code implementation that covered one use case, I wanted to take a higher level view of event-driven architecture, and hopefully help provide some guidance trying to make that transition within their own project organizations. So event-driven architecture has been around for a long time, but it's really grown in popularity over the last 5 years. Became more of a buzzword recently, primarily due to the more distributed systems as well as microservices. And then along with that, the tooling much more with the kind of the rise in the cloud platforms become much better. So first off, I do want to cover some messaging basics. For those people that might have any experience with messaging, just want to kind of level set the group on some of the core basics there. Then we'll run through some specific examples that pulled out the builder trend, and go into more details of the pros and cons of a few different approaches. And then I'll wrap up. Like I said in the synopsis, this is a huge topic. So I want to make sure we run through some of the important decision factors that some of the decisions you have to make when you're first implementing any level of event-driven architecture. And there will be a few things I might not have time to discuss. We'll kind of play it by ear. If we have time, we can have some just open discussions about them at the end, but I'll at least have it listed out so you can see some of the things you have to be aware of as you start rolling something like this out. So a few key concepts, really queues, events, and whatever you want to call it, orchestration, workflow, stream processing. I'm not going to actually dive into anything related to SOA or microservices. Services in general are really a large part of any event-driven architecture, and they'll work with everything we're talking about today, so I'm not going to dive into that side of it at all. So queues have been around for a long time. They were pretty painful to use and manage. Think like MSMQ. Don't think I've ever spoken with anyone that really enjoyed working with it. But really the basics is you have one message processor. You might have a lot of things publishing to it, but you typically have first in, first out, or typically a lot of times you'll have order delivery, but you always have the guaranteed at least at once or guaranteed once message delivery. But essentially the publisher to the queue, they know what the message is for. So I'm publishing to like a notification, or I'm publishing to a ticket, a ticket reservation queue. It's kind of a command message style where the publisher is essentially just giving something else a command to go do something. So an example there is like when you're reserving concert tickets, if you're on Ticketmaster or any other online platform, when you actually view the tickets and select your tickets, it'll send it through some sort of queue. They make sure there's the seats available, block them off for you while you go and do the checkout. So that's a pretty basic standard queuing type of system. From an event perspective, I do want to cover one definition or a couple definitions going into this because there's some confusion. Topics and subscriptions have really kind of become the standard nomenclature for the actual mechanisms that pull them or house the messages. Where there isn't a lot of standards right now is still on the who's sending and who's receiving. So there's a couple organizations go by publisher subscriber. I think Kafka still goes by producer consumer. Microsoft for a long time went by sender receiver. That's the only one I really have a bit of an issue with since it depends on perspective. If you're saying something's a receiver, is the topic a receiver, or is the process that's receiving the message? So that's the point of confusion. I think they might have gone away from that with Event Grid, but I'm not positive there. But all of those are really the same thing. It's something's publishing, and something's retrieving or subscribing to those messages. So generally, the most common scenario is what I have shown here. You have one publisher and many subscribers. And it can really, with PubSub or any of these technologies, it can really be about anything. You can do the one-to-one or many-to-one, which is essentially a queue, or you can do a many-to-many as well. There's not as many use cases for that, but there's use cases for it. When the message comes in and is published to the topic, the underlying system will distribute that to all of the impacted subscribers. So some systems or some products offer subscription filtering, and so messages may or may not go there depending on a set of filters. But typically, the topic, when the message gets pushed to subscription, that's where it guarantees the at least once delivery. It has a lot of the same benefits of queuing, a lot of the same basic concepts, but it is definitely more flexible when you talk about, you have things like the message filtering, like I mentioned. So typically with an event, you're not, and this depends who you talk to, but typically you're not adding a lot of data. You're not publishing a ton of data with an event. It's really a pointer back to something, or you're really just kind of telling others what might have happened in a system. The counter to that would be event streaming. You'll see this, it's really common in data analytics, especially in with IoT devices where they don't have long-term storage or it's not accessible long-term storage. And so in those cases, you'll have, those devices will stream everything down to a centralized system. And so you'll have a topic that accepts those messages, and that's actually publishing the whole message down within the system. It's also pretty common for logs as well. It's kind of where there's no centralized storage. An example here is, think about when you submit a change of address in the post office. The post office processes that change of address, but behind the scenes, there's actually a lot of things going on. And I don't know, people have noticed recently, a lot of financial institutions may subscribe to that, where it'll automatically update your address behind the scenes. You'll get notices saying, hey, confirm that your address changed. And then of course you have the umpteen marketing agencies that also subscribe to those changes, and then you get dumped with a bunch of mail over the next 6 months or so. But that's just a very simplistic common scenario that people, if you look at it, you'll run into those, you'll see that. So this concept, orchestration, stream processing, workflows, however you want to call it, it's really any process that, any multi-stage process. It's really, you're taking a message, you're enriching it along its path. Each step may or may not move that message on to another step inside of a workflow or another stage in a workflow. But really, it's any multi-stage business process or workflow is a candidate for something like this. There's also scenarios where a request may require multiple stages before returning a response to a user. So think about something like Expedia. If I'm going to Expedia and I submit my information, underneath the hood is triggering calls to multiple external services to get pricing from different providers. But at the same time, it's also retrieving its own promotional information. Like when that request comes back, you also have car and hotel package offerings and things like that. So it's accumulating all that, or aggregating all that information under the hood and then returning that combined response to the user. That's another thing that's kind of a standard orchestration type of process. So there are two patterns, I'd say two common patterns, there's not more out there, but the two most common patterns are the mediator pattern. And this is where you have a centralized processor or router that manages how every message that goes through that system is processed. And so that mediator will take the message and then it'll send it to each of the appropriate processors under the hood. In some cases, it might wait for a response to come back to guarantee that it was complete before it sends it on to the next, things like that. There's a lot of products available for this. Some of the older school products like BizTalk, Neuron ESB, Oracle, IBM have products available for it. Lately, a lot more cloud offerings are popping up. I know AWS has a workflow service. Azure keeps building on the logic apps. Those all kind of serve that same purpose. And then on the data side, there's just tons of tools on the data side for ELT data processing within all the cloud platforms that do something similar. The other really common pattern for this kind of workflow orchestration is a broker pattern. And this is where we don't have any central authority over what's going on or how things are processed. Each individual step in a workflow or process will push it on to the subsequent steps. So, that change of address, or the message comes in, it goes to processor A, that does whatever it needs to do, might add to the message, might not, and then it sends it on to the next step in the workflow. So a good example of something like an orchestration would be, think like a mortgage application or the mortgage process when you're buying a home. You got to fill that application. Think of that application as a message going into the system within the mediator pattern. That mediator would then send something off for a credit check, and then it would send off another message or another event to get a home valuation done. And there's the other process that gets kicked off for running the financing. So you kind of have a multi-stage thing, like a big business process that you want to manage together. You want to make sure that message gets from point A all the way to the end of the process. So the fourth one, this isn't really a definition. It's more of me just wanting to stress how important monitoring is in any event-driven architecture. It's really any solution, but especially in an event-driven architecture. If you're doing basic queuing or pub sub, you can often get by, and I mean get by with logging and error reporting. But if you're jumping on and kind of getting more advanced and doing any sort of orchestration or workflows, or you just don't want to randomly pull your hair out when you're trying to verify whether or not some specific message got processed, then a more complete monitoring solution is really needed. A lot of logging and error reporting tools, like we use Sentry.io, they have tracing capabilities. And so that essentially a message gets tagged with some sort of identifier, usually something like a GUID. And then that message, that ID gets propagated all the way through the various processing steps the message goes through. And it gives you a really basic end-to-end view of every message that goes through your system. And it also makes it very easy to tie those messages back to any logging messages or any errors that happen along the way. Most mediator or service bus tools out there have some level of process monitoring baked in. You just have to kind of determine if it's sufficient or not. Typically, when I've worked on these systems in the past, where we have rolled our own kind of process tracking or process monitoring solution. Always the basics is you have a high level view of that has all of your processes, maybe the number of messages that went through it, the number of errors, things like that. Then you can drill down kind of this grid type of view, and then you can drill down into individual messages to see where they are at any stage in the process. Now, some workflow tools, I think the one on the right is actually Nintex. It's a tool I've used in the past where it's more kind of like the human hybrid workflows. Some of them will have these the more designer view, where you can actually, after you drill down into an individual message, you can see where that message is sitting within the workflow. So now I want to run through a few more detailed examples that we pull from Bill of Trends. Some of these are actually past states, some are future states. A couple I made up completely. I want to walk through the kind of what a progression can look like or could look like for a few scenarios, and talk through some of the pros and cons of each of these different scenarios. So, really common scenario, especially if you're on any existing legacy system. This is the no messaging at all, right? This is how most systems are still built. So hopefully you're at least going through, this is a notification scenario. So within our solution, we have a ton of entities. Many of them send out notifications to end users. So whether it's end users or whether it's support personnel. And so we have, in this case, typically central notification business logic. So there's not really a lot of code duplication. But each location that notification is needed, we'll call into that business logic, and then that business logic will send it through. Like in our case, we utilize a lot of Firebase, a lot of SendGrid. So the pros of that, obviously, it's extremely simplistic. The code is very readable. From any entity, I can walk through with no problem, see exactly what's happening to every message in the system. And then you're guaranteed that it's real-time integration. If that request comes back, you know that everything under the hood happened. The cons of this, the obvious one is it's fragile. So what happens if Firebase or SendGrid are down? Like we actually had this today. Firebase was intermittent this morning, and so we had a bunch of messages that were getting kicked back from Firebase. Or what if we hit a limit and like a API limit and calls start failing? We have 2 or 3 integrations that have pretty tight API limits that we have to manage. And so when those calls start failing, if we're doing a live stream like this, or a live non-queue system like this, those calls were actually impacting our APIs most likely on the front end, and those potentially front end users. So, and then as more processes are added, those API response times start getting adversely impacted because all of those backend business processes take some sort of latency that you're working with. Another really common big one here is the API layer is now tightly coupled to all the backend processes. So any event, even if you're injecting the dependencies, you can to simplify testing, but at runtime, that coupling is still there. All that still happens in line. And then there's some code duplication. Again, ideally, if it's written well with standard coding practices, there's not a lot. But like in our case, I think we have 70 plus areas that were originally sending these notifications. So something you definitely will run into. Now, taking that same scenario and just kind of taking it to the next step, we're just introducing queues in this case. And so again, really common situation, definitely nothing new, just easier now than it used to be. These have been commonly used for years for isolating some expensive external calls or expensive business processes, fragile or unstable endpoints. If you have third parties you work with that they're not up overnight, or they have a lot of batch processing, and overnight their responses kind of go to crap. Or if you're handling for downtime for your own processes. So in this case, all we're doing is adding a queue, or a one-to-one topic subscription is what we actually what we do. Rather than directly calling notification logic, each of those entities are just publishing a message that the notification is needed. So obviously the pros here, we're a little more decoupled than we were before, because now we're just going to a publisher and not to that individual process, a third party. This definitely improves the API response time as those dependencies are pushed off. And then in general, we're more reliable and scalable because these publishing systems, whether it's GCP, Kafka, Azure, any of these systems, those are really designed for speed and reliability like I said, with any platform you go to. So your reliability definitely takes a big step upwards. On the con side, we are still slightly coupled because all of those business logic layers, they're still pushing that message. And so we still have some of that coupling. They still know about what's happening behind the scenes. And it, as well as does add some process latency. And so when we talk about it, it's amazing how often you hear when you start talking with business users how near real time is initially deemed as completely unacceptable until you actually really work through what the business scenario is. And you can demonstrate that, hey, maybe a couple seconds is actually okay. And so it's something you have to watch for. And it's as you start evangelizing something like this in the business, when you want to start pulling these things out and decoupling the events, it's something you will run into that you'll want to make sure you can address. And most of it is really just typically a conversation that, oh, it might be an issue here, but if we do this slightly different change, then it's completely invisible to the user and might not be an issue anymore. And like I just mentioned, the business logic is still slightly coupled. And so when let's say the code for a builder status change publishes a message to the queue to trigger notification. Well, now if I want to add in something like an activity feed, that has a lot of similar areas, a lot of similar places within our services that trigger it. Well, we're now adding another publish in all of those areas, all those entities within our business logic. Or then we go and add in something like the Salesforce sync. Again, I'm going back and now I'm adding within those business APIs, I'm adding additional publishes to the Salesforce sync, even though there could be some duplication. So in some cases, we now have business logic that's aware of multiple backend processes. That's still that coupling that we have, even if it's all going through something like a pub sub. Those business entities all have knowledge of what's happening in those disconnected processes. So we have something like if I wanted to remove a notification, that entity still has to be updated to no longer push the message. So I still have that back and forth tie between the end business processes and our actual business logic. So the way we further decouple that is with more of a true event pattern. So the basic concept is pretty straightforward. If there's a change to like a builder or a user, we simply publish out a message saying what business event happened. So in our case, it could be like a builder canceled or a user was created. So we're publishing out that business event, and then the business logic now it just controls and cares about its own logic. The only addition is that we are simply publishing a message to the other process, or publishing a message so that other processes that might care about that event, business event, can act on it appropriately. So in this case, each entity publishes a message for the desired business events, and those secondary processes can decide which events they actually care about and subscribe to only those events. The real strength when utilizing events in this way is that changes to an existing business process or a new requirement has a much lower likelihood of actually impacting your core business logic. So if a business determines that user's to-dos should now be synced over to Salesforce, the sync process can just subscribe to the to-do events that are already published and begin processing those. Or if an activity feed is too noisy for a user, the activity feed process can simply stop pulling from or stop subscribing to whichever subscription is causing that unwanted noise. So this really gets to a place where we fully decouple those external business processes from our core business logic. The cons of this one, it really is the biggest challenge the biggest challenges and most of the conversations and complexity around implementing an event-driven pattern is almost always around what constitutes a business event, and then determining what should be published as part of that message. So I'm going to dive into that a little bit later, just because it's a bigger topic, so I kind of give its own section in a little bit here. So on a complete side tangent, for those that you don't know, eventing is actually an equestrian thing. Didn't know that until I started searching for funny eventing memes. So here's a sample of what you get. In general, memes around queuing and service bus and pub sub are pretty sad. So I didn't get anywhere near as many memes as I typically do in a presentation. So before jumping more into the weeds of some of the challenges with events, I did want to chat through a couple of the specific scenarios that I've had a lot of success with when first introducing events into an organization, especially when you're dealing with existing systems. So this is a really common scenario. For us, it's a new builder, but new account, new user, new application, however, whatever the kind of those initial onboarding business events are for your system. A lot of times, almost always, there's multiple things that happen when a new thing comes on board. So especially for us, we have a new builder. We have our marketing gets involved. We're going to send marketing emails, billing, our support team. There's a lot of things that need to happen when a new builder comes on board for us or a new account comes on board for us. So by implementing a status change event or an account created event within that business logic, it becomes pretty straightforward. That core business logic does whatever validations it needs over here to be able to accurately save that message. And then all it does is publish that, that status event or the creation event to our pub sub system, and then that allows all those external processes to pick it up. So marketing can pull that new account into their system, kick off the welcome email. The new account will get created in Salesforce, which then triggers our onboarding processes within that system. Like in our case, we have sample job information that we load into the builder's account to help them with their onboarding, give them as they move forward. And then the new account info is also sent over to our billing partner for setup there. So really the main pro here is we get all the benefits we spoke about before with the event-driven system, but we're starting small. You're picking one or two things, start small. You can iterate on top of that. And then as those business processes change, kind of what I said before, is as the business process changes, that core logic doesn't actually have to change. You can simply add or remove subscriptions as needed. So I do really like this pattern as a starting point when you're first kind of kicking the can with events. It's very simplistic. It's easy to understand, and more importantly, it's easy to explain to others within the organization. So it gives you a path to get approval for a change like this, rather than pitching that, hey, we need to do this full re-architecture of our system to become event-driven. It's you start with one or two of these types of really common scenarios that everyone's aware of what happens behind the scenes, where there's predefined benefits. You get these big wins right out of the gate where you can demonstrate that your response time was reduced on the initial calls. You can use it as response or mitigation to issues that have happened in the past, where maybe in this case the billing setup failed, and then it aired out on the user, and they didn't know what happened there, so they ended up creating a duplicate account or something like that. So you can use it from a business justification perspective. It's pretty easy to find scenarios like this where you can where you can kind of pitch it and justify this as hey, this is where we can find a lot of value. And then once you get a few big wins under your belt, you can start expanding it across your system. The one main con on this, or from a con perspective, is as you start rolling out events, it's really easy to kind of end up in an event overload state. So let's say we went really granular and we have an account created event. Well, now things happen on account canceled, on an account suspended, on account re-sign up. All of those scenarios just keep adding to the events. So as you roll that out across your platform, you can kind of end up in that event overload state. So there's a lot of opportunity. It's something where this is just like everything else in development. It's got to be pretty iterative. So there's opportunities to regroup the event. So if you have, hey, similar process happen in all of these different account status change types of things, maybe it should be an account status change event. But that goes back to the biggest one, like I said, the biggest challenge a little bit ago. What are those business events and what should be published along with them? But either way, by baby stepping it, by doing a couple of these types of really distinct scenarios to start out with, you'll have better knowledge of what you actually need in those other processes. And then, like I said, you expect everything we do is iterative in development. So expect a little bit of rework, but by doing it this way, we're just reworking maybe a couple processes as we kind of figure out how we want to manage something before, rather than going through 10, 20 processes out of the gate. Another almost no-brainer in my mind for any event or queuing type of solution is third-party integrations. So we have a lot of B2B integrations. About the last thing you ever want to do as a company is go to a partner and ask them to resend messages to you. And this also provides a lot more flexibility within your organization. So when you have a partner randomly send 100,000 messages in a minute, and it turns out it's because they were down for a couple hours, if your process can't handle that many messages, this basically lets you throttle what's coming through your system so that you don't start bombing out as well. Or if a bug gets pushed out to production that impacts just some types of messages, you can pause that processing until a fix is out there and you're not impacting any front-end systems with it. Another common scenario that we run into probably way too frequently is when a third party is down. Or like I said this morning, Firebase was intermittent. Well, we started getting a lot of errors back from there. We can simply pause that processor. The messages will stack up within our subscription, and then we can kind of open the gates again once we're confirmed that third party is back up and running consistently. So we have a lot of integration partners, and kind of going back and forth is usually we're calling each other's APIs as data changes. You have status updates for longer running processes. We have video processing. We have insurance platforms that we work with that are, sometimes take multiple days. And so we have a lot of webhooks going back and forth, a lot of new accounts, leads, things like that. So all of these have been kind of excellent fits into this model. And it's honestly saved us a lot of headache along the way, just in these weird little scenarios where, yeah, this system's down or there's some bug got introduced here, like the ones I mentioned there. So really, any integration that doesn't have to be real time, we automatically push to an event or a queue system. When you have real time scenarios, and when I say real time, I'm meaning human facing requests that impacts the customer or impacts like a business rep. That's where you wouldn't be able to use it in those cases, but we've had very few scenarios that have really run into that category. And if you had something more complex where you still wanted to do it, that's where you start talking about that kind of request orchestration style, but those can get pretty complex, so you have to have a strong business case to justify something like that. So jumping over, decisions to be made. I mentioned this a couple times already, but the biggest challenge whenever working with event-driven architectures that I've run into, at least, and I'm sure it's the same for most others, is deciding what constitutes a business event and then what goes in with that message payload. So some general kind of guidelines that I've found, I have a couple links later I'll make available to everyone as well. But really, ideally, you're trying to tie any event to a business event or a business process. So if I have, like I mentioned, we have a new account, so account creation, or like for us, those status changes, it's the creation, cancellation, suspension. There are a lot of business processes tied to those. So those are really kind of easy to identify events that we want to publish. So one of the main reasons for this is it's very simple for the subscribers to understand what the event is for, especially as more and more events get added to the system and you start kind of building that out. If your names are too generic, it's very difficult for anyone to utilize an existing subscription because they're not really sure what that's actually for. So as far as messages being generic, it can cause it's termed as leaky messages, but it's essentially those subscribers now need to know the details about the publisher in order to even process the message or to even understand what the message was for. And so you essentially create a reverse coupling from what you had before. So like I said, it makes determining that message payload. It also makes determining that message payload really difficult because, again, if it's a generic message, what do you actually need in that payload? Do you need to identify certain things that changed? Was it just because something is new, or it's very difficult to actually identify what should go in the payload when you have those generic messages. And then, like I said, this on the subscriber side is very difficult for the subscribers to know what's going on, especially like they have to have really intimate knowledge of the publisher to know if that event even means anything to them. So on the payload side, general guidance is really only add the required info that you actually need for the event. This is a lot more simplistic if you go with kind of more targeted business events. We talk about like the account status change. Well, for an account status change, all we really need is identifiers so someone can go back to that account, maybe call the account API and get more detailed information if they need it, and then maybe like an old and new status. So that message becomes extremely simplistic. Another fairly common style is the kind of patch style, where you're just including the identifiers and then the data that changed. The side effect of this one is it is pretty brittle. You have a larger contract that is shared between your publishers and subscribers. So you're essentially binding all subscribers of a system to the publisher's data model. It can be useful. There are some really positive use cases I've seen for this, but it can be very useful when syncing data between systems. That's more like event streaming I mentioned, where you're actually including that data in the event, and it's because you're trying to push it somewhere. And so you'll see the patch style quite a bit when you're trying to sync two data sources, like especially in like a migration scenario. You're trying to sync data source A to data source B while you're going through a migration to the second data source. One of the biggest downfalls of the patch style, though, is in most cases, you've now guaranteed that you must have message ordering. And I'm going to jump into that in a little bit here as well. But you're in most cases, you now require message ordering in order for your system to function. And then the other common one is the full payload. Very similar to the patch, you have that same brittleness where your subscribers and publishers all have to share that same data model. But again, it can be very useful for data syncs between systems. If you're doing those migration syncs, or you'll see a ton of this around data analytics, where you're actually streaming data into more of a central data lake or a central repository. And then the positive about doing the full object or full payload is you can typically get rid of that message ordering restriction that the patch style has, because in most cases you just want the most recent data. And so you can just process those messages and then just discard any out-of-date messages. So we do that for a couple of our systems, like our Salesforce account sync. We kind of have a time check in there where if we've already processed a message, a more recent message for a builder, we just discard any of those old messages. So we don't need the full playback within that other system. We just need the current data. So we don't have any ordering restrictions because we use that full payload rather than more of a patch style. The one big thing to understand in anything we do regards to message payload, these are contracts. So the more you add to it, the more that's in it, the more that you have to maintain. So you have to basically, when you're doing these types of things, you might have any number of subscribers that you may or may not have control over. So any breaking change you have, you automatically must version those contracts. And it's virtually identical to any API contract. When you have those breaking changes, you have to support the previous versions of those contracts. And you can do a lot of similar methodologies within events, within queuing, or within published subscription models. But there's a few more complexities related to it, but there's ways to work around it. But you have to understand that these are contracts. If I change that contract and just start publishing new messages, I could break any of those downstream subscribers. So something to definitely keep in mind. Jumping over, I mentioned the message ordering. This is something that there are definite use cases for it. There's places where it has to be done, but it's one of those ones where I highly, highly recommend have the conversation, because it's really simple for a dev that's not, especially not used to kind of an event style architecture. It's really simple for a dev to come in and say, oh no, these have to be in order because of XYZ. But again, you take a step back, look at what's actually happening under the business process. We've had that happen probably 3 or 4 times as we've been rolling some of this stuff out. And in every single case so far, we haven't actually needed the ordering. So like I mentioned, we've been able to get by it with, doing the last message in, things like that, kind of using some of those patterns to get around it. If you do have to, like some of the common use cases, I think they're pretty obvious. Like if you're handling inventory, like the tickets, things like that, you're doing any monetary adjustments, those types of things have to have order, and that's what this is for. But you really just need to be able to try to limit when you actually need it. If it is necessary, there are some platforms, we don't have the capability in GCP, but I know a couple of the other platforms do have kind of partition-based ordering, where I can set limits and say, okay, everything with this account ID has to be ordered. But then I can partition that account ID across consumers or across subscriptions, and that way I can still scale out. I still have the ability to scale out to some extent. But in general, ordering kind of kneecaps your ability to really massively scale any system. So if it's a low volume process, message ordering is not going to really cause much of an impact for you. But when you start talking any high volume operations, then it will end up causing some issues unless you can find ways to limit it or kind of partition it out, like I mentioned. And I also mentioned that typically ordering, there's a lot of ways you can work around it. That most recent message thing I mentioned, doing a really simplistic time check, like that took not even a couple hours to implement for all of and it's something we have just in our framework across the board now. Inserting via point in time, so every message that gets published has a timestamp. So if it's something where you're looking for historical tables or data analytics, you don't have to order those, because you can basically just insert them at that point in time to get that full replay capability within those the data lakes or the other systems. And I also mentioned like the full data versus patch. If the patching is going to cause issues where you have to order and there's not that much more data to just kind of publish the full data message, then it might be a worthwhile scenario to do that. Another big topic that you'll run into is deadlettering. This is something that, in general, if you don't know what it is, it's when you can't process a message. Whether you have, like I mentioned, someone broke the contract and now you have an invalid format, or you have just had bad data, someone else published accidentally to a different process. Deadlettering is really just the mechanism to move that message out of the subscription or the queue, so you stop trying to process it. You can do that through there's max retries, there's timeouts, there's all sorts of other options depending on the platform that you're on. But the issue is, if you don't handle the dead letters, they become essentially poison messages, where if you get a few of them, they can slow down or actually freeze your processing and really wreaks havoc on both error reports and your subscriptions in general. So like with GCP, I think it's the only provider that I saw, that's the only one I've seen recently that actually doesn't have it. But we were able to go in, and when we first rolled out, we rolled our own dead lettering really simplistically using Redis and cloud storage. And it took a day or so that we had to do it, but it's worked out really well. And we've been told it's being worked on, but that's something we can't. If you're implementing something like this, you can't wait for a third party to implement something like dead lettering. That's a must-have out of the gate. Like I said, the good thing is almost every provider has dead lettering baked into their products. But really, from a what is needed perspective, even though they have it baked in their products, some of them handle it differently. And so you want to set up your pattern of how you want to use. You want to set up, what is my standard retry logic? What types of errors do I want to dead letter on? And then what's your recovery from that? Even if it's manual out of the gate, which is fine, might not. When you're first just testing the waters with doing queuing or doing events, you probably don't want to have to build an entire operational system that lets lets anyone go in there and reprocess messages through a UI. That might not be worth it. You want to try it out first. but at least having that process to know that, okay, if we have a dead letter, this is how we're going to recover from it, and this is how we're going to reprocess that message if needed. So really, the goal is here is just to the last point on the dead letter, you got to make sure there is some sort of monitoring of the dead letter queues. Like I said, all of them have dead lettering baked in. Some of the platforms do not really have any monitoring there at all. It'll just publish to like another topic that's a dead letter topic, or it'll just go into some bucket behind the scenes. And so obviously, if you can automate this monitoring, that's definitely preferred. But you don't want to end up in a scenario where you've been dead lettering 10 messages a day for the last 2 weeks and just no one caught it. And so you're missing potentially critical business processes just because no one was monitoring that queue. So that's kind of out of the gate. You have to at least do some basics, even if you don't have a lot of fancy processing around it or reprocessing capabilities. You at least want to make sure you target those specific scenarios. Another one I wanted to hit on, this is one that's really easily overlooked, is the development environment. And this is extremely platform dependent because you have things like Kafka, we're using PubSub, done the same thing with Service Bus. Some of those have, like installable offerings. Some don't. And so you want to actually look at if you're deciding on a platform, that's something I would definitely look at. If you already have a platform, you just got to see what's available. Like in our case, we have a PubSub emulator. Azure Service Bus has a Service Bus emulator as well. They're not phenomenal tools, but they get the job done. And so we're looking right now, we're actually kind of doing a dev container. And so we're going to roll that into our container as well. And so that way it's just automatically, devs all have direct access to it. And it's just a config change and everything works like you would expect it to work. But it's something you want to definitely want to look at early on. We didn't look at it right out of the gate. We had a rough way to do it. But it caused some heartaches early on when we started pushing more things over. As we pushed more critical business processes over to events, we definitely had a few heartaches that we had to work through, and that's when we rolled out the emulator and started working through that. But really with events, it can be a lot more difficult for developers and testers to know what's going on. The true beneficial thing is that they really shouldn't have to, in their day-to-day, shouldn't really have to know what's going on. They just need to ensure that each individual process is doing what it's supposed to be doing. And then that if you change a message contract, that's when you have to start looking at those other areas with the versioning and potential impacts, integration testing, things like that. But it definitely still can be a difficult transition for devs. So you want to make sure you at least have a way that a fairly simple way that the devs can stand up to do that end-to-end processing, end-to-end testing. The last few kind of what I termed as the must-have decisions are these guys. The push versus pull conversation, that's actually become more important recently. There used to not be a lot of push options available, but really, like even the reason I say it got more important is now like Azure has split up the products. So if you want to do push, they used to kind of push for Azure Service Bus that, you can do push notifications in there, and I think you might still be able to do some of that. But really their guidance is you should be using Azure Event Grid. If you want to do anything push, you should be using Event Grid. If you want to do polling, you can't do that in Event Grid, you should be using Azure Service Bus. And so now there's actually product decisions being made off of this. It used to be something you could just kind of hold off on. Honestly, like in our case, we haven't even pushed this a whole lot as a topic because GCP rolls them both together. So I can take any existing subscription and then give it an endpoint and turn it into a push subscription. But now other platforms some of them aren't kind of going that route, so you have to make that decision pretty early on. The push is really, the biggest benefit is they provide, I say two biggest benefits. They provide lower latency because there isn't that pull. You're not doing whatever, even that pull interval, even if it's 5 seconds, that's still 5 seconds that you're missing out on the processing if it does wait that long. So the push is almost immediate. You get that true, like really close to real time type of processing capabilities. There are typically some tighter limits around it. Usually around throughput and response time. So I know on GCP when we do, it has kind of expected response time. You have some extra complexity around back off times as well. So if they're pushing too much, if when you set up a push, if they start pushing and you can't handle it, you have to actually send some kind of in the response telling it to slow down a bit, and then it'll tell those systems to back off a little bit and kind of slow how fast it's sending those messages. So there's a little more complexity when you're dealing with pushes, but you do get that near real-time latency, and you also get I can just deploy those out as APIs or cloud functions or whatever else. I don't actually have to have a background process that's going pulling the messages out of it. The pull side, it really gives you the biggest benefits there. It gives you more control over throughput and timing. Like I said, we had the case where one of our vendors spit out about 100,000 messages in a minute, and it was something that that specific subsystem we have could not handle that, but we didn't have any issues at all because we have that throttled through our pulling. We pull X number of messages at a time, so we spin up. In that case, I think we do like 10 or 20 messages at a time and process those. So it just churned through it, and then within 30 minutes it had caught up and we were fine. So you get that control of that throughput, and you get more control over timing. So if you run into issues where you can't process certain things because this subsystem or this third party is only active for certain hours of the day, or they have known downtimes that they run through, you can actually automatically pause the subscriptions during those times, and then just the message will back up, and then once they're up and running, you can just kick it back off again. So you give you a little more flexibility control over how those messages are processed. Typically, you'll have a slightly higher latency. For most of our stuff, we just check every 30 seconds, and it'll run until everything's processed, and we have 30 seconds again. Those are things where we don't have anything visible to customers or any really critical business processes. And then we have some that run every 5 seconds. So again, we have that control. We are starting to look a little more at some of the push options as well. The GCP side, Cloud Functions not having any .NET stuff has been kind of annoying, but we have a few Node.js functions out there now that we're working with. Subscription filtering is another one that a lot of people might not agree with this one, but I put this in the must-have category, right along with the dead letter and some other ones we just talked about. Because really, as you start gaining in any sort of complexity with your events or your queuing, you're gonna, in this primarily events, but you're gonna run into the need to actually filter messages at a subscription level. And it's typically done, and all the ones I've worked with, it's done based on message attributes. So you can always add custom attributes to messages, and you can filter off of those attributes. So I've used this one. The reason I put it in the must-have is I've used it really heavily in the past for contract versioning as well as message replay. So if you think of like an event system, when someone publishes a message out, let's say it goes to 4 subscribers, only one of them fails. That one that fails, I can't publish a message directly to a subscription. I'm running it through that topic again. And so it's almost trivial if you have message filtering, it's almost trivial to say, I have a replay attribute, and when that attribute exists, the subscriptions will filter on their name. And so if their name is in that attribute, then it'll pull the message in, otherwise it won't. And so it's almost like the implementation for replay becomes almost trivial because of the message filtering. The other thing, like I mentioned, the versioning is the same type of thing. Is if you look at some common versioning patterns, kind of scary where you start standing up separate subscriptions and separate topics for every version. And there's quite a few of those patterns out there. And from an operational perspective, it's kind of a nightmare because you start supporting 3 or 4 versions depending on how distributed, and if you're working with third parties, of these topics and subscriptions, it can get out of hand really. I talked about event overloading, then you get to the point where you just have so many topics and subscriptions, it becomes just a complete mess. So you can do the same thing here and pretty simply implement versioning just using message attributes and subscription filtering. And so those are just 2 out of the box ones. There's also a lot of functionality you can do with them from a scaling perspective. If you have super critical accounts that you have like kind of watch really closely, you can funnel them off into their own subscription and have all the other subscriptions process everything else. There's a lot of kind of fine tuning that you can do with it. But again, that's why I kind of put that in the must-have category. That's been probably our biggest challenge we've had with GCP is that they actually don't currently have that. We've been told they're bringing it on, but I know I've used it heavily in Azure Service Bus. I know EventGrid has it. Kafka has a variation of it as well within their partitioning. So I believe all the other providers do have that out of the box. Last one here would be scaling. This one, in general, like I said, these platforms have been built for reliability and scalability. That's really, if you look at any of GCP's data analytics architectures, their reference architectures, same with Azure, a lot of Hadoop ones have it too. These types of systems, these pub sub systems, are the cornerstone of almost every single architecture you'll see. And so even like when you're going through the streaming, if you're using third-party tools that do data streaming, a lot of them still stream through these types of systems. And so the good thing is pretty much all of them can scale very easily. The reason I threw this on the list is that they do scale slightly differently. So if you look at something like, I believe the AWS Simple Notification Service and the Azure one, those ones are region-based. And so if I'm in central region, they are tied to that region. And so it's really good because that allows those platforms to enforce message ordering. It also can simplify some network or security concerns depending on how locked down you're trying to make something. The downside of that is that you now have to code for your own failover. So if you're talking like a disaster recovery scenario, or if you're expanding to multiple regions, you have to code to handle that cross-region traffic. Versus like the GCP pub sub offering, that is global by default. The big downside is they can't do certain things like that message ordering. Just from a global scale perspective, when those things are coming in, it's not feasible for them to actually allow a message ordering option. The great thing is we don't have to implement any sort of DR or anything like that around it. Eventually, we're going to do we're starting to look at some multi-cloud stuff. So eventually, we're going to have some failovers going over to either Azure or AWS. But that's all we're going to have to deal with. We're not going to be dealing really with anything within the GCP realm. And the other thing it gives us is kind of, because it's built for massive scale, it gives us the number of topics and subscriptions and message throughput are absolutely absurdly high. So we're doing a few million messages a month, or actually I think we're like 30 million a month, 20 to 30 million a month. And we're not even scratching the surface on this thing. And we're in the, well less than 1% of any limits that we need to look at. So that is kind of nice. But at the same time, if we want to do message ordering within that platform, we have to roll it our own. So that's one of those ones where the whole multi-cloud, these implementations are fairly straightforward, honestly. So multi-cloud from a messaging perspective is, if we end up something that truly needs message ordering, that's something we'll probably end up looking at another provider for and seeing, am I having just an implementation for those specific use cases. So I had these ones under keep in mind, just because, again, I didn't know how much time I'd have left over at the end here. These can be important. Like I mentioned, it's not a huge topic, and each one of these things you can spend a lot of time talking about. But depending on your organization, a couple of these might become critical. Like if you're working in healthcare, that encryption is a must-have, or financials. If you need PCI, if you're dealing with HIPAA, or if you need to have PCI certifications, these are things that are at rest. These messages are at rest while they're in the queues or in the subscriptions. So you have to have encryption at rest for those to satisfy those requirements. And all the different platforms kind of handle that. Some do it by default. Some you can specify custom encryption keys. Some you can't. So some that might be really important to somebody else, but not always. Another thing you look at is like the standardizing metadata. If you're really starting to roll this out, getting big, that can help with logging. It can help with your traceability between systems. So that might be something you want to do earlier than later. Like for our case, we identified like 3 or 4 things that we want in every message, and we haven't gone back to it yet. It's been over a year, a little over a year since we've fully implemented some of these things, and we haven't had any issues with it. But this for some organizations that might be important. The other ones here, serialization, like we rolled our own on that one, just supporting both JSON, and I think everything we have going through there's actually JSON at this point. We had supported binary initially. We're kind of phasing that out. Message replay I mentioned is something that we pushed off because, again, you can spend a ton of time on that, maybe not have a ton of benefit for it as long as you have a way to do it. Message duplication is another one that's very platform specific. Some of the platforms, you can check a box and it deduces messages for you. Some you can't do that. And so that's something that you might need to, if it's a really critical process where you have to guarantee only once, that's why all of these platforms say guarantee at least once delivery. If you need guaranteed only once, then you have to make sure you handle that within your system. We have a couple places that do that. We just use basic hash logic. You get a combination of Redis and hash logic, and just to make sure that we're not sending through the same message multiple times. Transactions is one that's less critical now than it used to be. There's, I think, Azure Service Bus officially supports it. Most of them don't. You usually have to kind of handle your own rollback functionality. In most of our cases, if we're doing publishes as part of like we're within a SQL transaction, we do a publish. We just basically hold that publish until at the tail end. After the transaction scopes out, after the transaction is actually completed, so we're not holding up SQL Server, then we publish those messages out. Things like that. DR failover I mentioned briefly. So these are all kind of things that we can talk a lot about. And if you have questions about them, we can definitely dive into them a little more. I just wanted to get that list of things out there. So if you're just starting out on, these might be important to you. You got to kind of make that determination for yourself, and then you can figure out how to handle them. I did mention a few of the links. These are a lot of good ones. Like I said, the four obvious choices depending on where your organization is. Azure's got multiple offerings. They still have Azure Service Bus. Truthfully, I feel like they're pushing almost everyone to Event Grid now. The only guidance I saw, I think it might be in one of those links that's up there, is if you have to do order messaging, you still have to use Service Bus. Event Grid doesn't support that. But they really are pushing people to Event Grid now. There's definitely some cool capabilities in there. GCP just has one. They have PubSub. AWS actually has a couple. They have a queuing service. They have their simple notification service as well. Kafka is another really big one. It's an Apache Kafka. That thing is used pretty heavily across the board. Most of the other platforms have, like within GCP, it's one of the third-party platform add-ons. I can just add it on and spin up a cluster within any of my GCP projects. So they make it pretty easy at this point. Kafka, it used to be known much more for that workflow orchestration. They have some some patterns in place that really lend themselves well to that message enrichment, that stream style processing, versus a standard kind of PubSub. You're doing more of that yourself. A good message ordering one, this is more just Google saying why you shouldn't have message ordering. Has nothing to do with the fact that they can't support it, I'm sure. But they actually have a very good explanation of why it's a detriment to scaling, and then as well as a couple common workarounds when you don't need it. And they have a couple options in there if you do need it. They have a couple of things that, hey, you can do X, Y, Z. So it's a pretty decent read. One of the best ones on here is that messaging anti-patterns. That blog post goes into a lot of really good common pitfalls that you can dive into. I've touched on a few of them on this talk, but there's quite a few more that he has in there. That's definitely a recommended read for anyone even dipping their toes in the water on this, is that anti-patterns. So I didn't get any interruptions, so I'm hoping that means I'm still on, but yeah, I can hear you. All right. Okay, we're gonna go ahead and actually drop this stream now, and we'll be right back in a few seconds so we can go through some kind of more open conversation on this. Matt's got to do some magic on his side to get the audio set up correctly. All right, while Matt's doing that, I'm gonna run through, see if there's any more questions in here, because I think his audio cut out at some point, so he couldn't chime in with questions. So give me a minute, I'm gonna run through some of these, and Matt's gonna try to get some stuff fixed on his side. And if you have any questions, please throw them on that Slack channel. Yep, I jumped on the Slack channel, yeah. All right, ensuring the architecture ages well. Yeah, that's one of the, honestly, if you look at the anti-patterns, that's probably one of your best bets, to kind of go through that and make sure you're not, because the most common thing you'll run into as far as having it not age well is when you start ending up in those situations where you're doing the, that major event, get event overloads, you end up with just hundreds of topics and subscriptions out there that no one knows how to maintain. That's the biggest thing you're going to run into. The nice thing about this is, like I said, it plays really well with any of the service architectures. So when you're dealing with, it's almost a must-have with to really get clean microservices, to have some of these types of things to kick off these processes. The other one is kind of the tooling choices you use. I have Brewer's on here, but I worked with him on a project that did some of this stuff several years back, and we kind of went through a couple different tools that turned out, one of them that turned out not to be great, and so we ended up having to do a lot of rework to get off of that. So the really nice thing, again, I think a few years back it was a lot easier to go off the rails on this, but it's been around enough where if you look at some of the really common patterns and anti-patterns, I think it's pretty easy to kind of have a stable, kind of put together a stable system. So like I said, I would say as far as, it's just like any other development, if you're trying to keep this from aging poorly, it's just making sure you're following what the current anti-patterns are and making sure you're not doing those things. And again, you're still iterating as you go. So that's really the main. Kind of jumping over, next one that Matt had on there, the event monitoring. That's one place where we're not really strong right now. Like I said, in the past, I've had several projects where I've put together more of a process, just our own process monitoring solution. And what I've done for those is I typically have, I mentioned that event tracing, like we're starting down that path with Sentry, where we have those trace IDs. And so what we're working on is we're gonna have an identifier on every message. And so we'll propagate that through headers on service calls. And so then any logging and any errors that happen between the service calls or between message processors are all tied together. And it's a really simplistic way to do it. Like you don't honestly even need a UI around it, as long as that database, the data is available somewhere, whether it's in BigQuery or SQL. It's a really simplistic thing that you can do out of the gate, like taking less than a week of work and have that almost end to end on everything you're doing. And you can just query on those IDs and get the full view of what's happened to those messages. Ideally, it's a little bit nicer than that, and I think we'll eventually get there. In the past, I've done a couple, like I mentioned, I think we just call it process tracking. I've had 2 or 3 projects that I worked on in the past where we actually put together a really simplistic UI around it. And I showed that grid view early on. It really was, here's all the processes. We had it categorized by system. We had all the processes shown. And then I could drill down and see every individual message that went through there, or if it had errors, I could click on the errors and it would take me directly to those error messages. So it really all starts from a monitoring perspective. It starts to making sure that you can actually trace those messages as they go through the different parts of your system and as they go through different APIs. If you have that in place, the other stuff you can figure out how you want to best implement it. Like I said, some of the bigger tools, if you're using one of the bigger tools, they do have some of that out of the box. The ones I've used haven't been great, so we've pretty much always ended up rolling some flavor of our own. Usually we have a high level view and that just taps into current systems. Like the one we're doing now, we're tapping into Sentry for all of our error handling or error logging. Then we're going to tap into Stackdriver for all of our just dev logging. But so we're not rebuilding those areas, we're using them, but we're just going to have kind of an overarching process level view of the stuff that we're processing. All right. Let me run through what do we got here. Oh, the tools, yeah. So we're all of our whole infrastructure. Yes, thank you. Okay, sorry, I thought Brian was on there too. So the one that Brian posted out in Slack is what tools we're using to handling the eventing. From our perspective, right now everything's actually out in GCP. So we are using GCP PubSub to handle all of our as the base for all of our eventing. Like I said, from the area handling perspective, we're rolling everything over to we had a homegrown system. We're rolling everything over to Century. It's actually a pretty slick system. We're using that for our front end errors as well. And then we have Stackdriver. Again, it's another GCP tool. Stackdriver handles all of our logging, and we have a lot of alerting and stuff like that we pull out of the Stackdriver logging. We did have to roll that whole dead letter monitoring portion. We had to roll that in ourselves, and so we're using cloud storage to actually house all the dead letter messages. That's actually worked out really slick for us, because rather than having separate dead letter queues for every single subscription, we have one that has the metadata tied to it. And so we have several cases where we have auto reprocessing, especially like we have some older email system we're having to deal or work with. Auto retry. We actually have auto retry. We have just a process that runs in the back, schedule process that Chris triggered every like 30 minutes or something, and we'll automatically retry those messages. So that's kind of our core group of technology we're utilizing for our event system. Send them through. All right, Matt. Yeah, how do we handle message versioning? We have not had to do this yet here. In the past, I briefly alluded to it, but I can definitely expand on it. The simplest way I ran into, or I've found to do this, is again through the message attributes and the subscription filtering. So typically on a publisher, when a publisher changes the version of the message, you can't, like I said, it's very similar to API versioning. When I'm a publisher and I change the version of a message, I'm changing that contract. I cannot assume that all subscribers are going to be able to upgrade their version at the same time. So what you actually do is, again, almost identical to like strict API versioning policy, is I have to support X number of versions, and I basically give the subscribers time to upgrade to the newer version. So I'll publish multiple messages. I'll publish a version 1 and a version 2 message. And then those subscriptions, each of those messages will have an attribute. That event will have a version 1, a version attribute with the version number on it. And so the one will have the version 1 attribute, one will have the version 2 attribute. And then on the subscriber side, when I'm setting up a subscription, I'm actually going to just subscribe. I'm using that filtering to subscribe to a specific version. So I know that I'm supporting version 1, so I'm going to subscribe to only messages that come through with the version 1 attribute. So we haven't been able to implement that yet. That's one of the ones I'm waiting on. We've been talking to with a Google architect a while back and talked through this quite a bit. And so they're working on it. So we've held off kind of trying to roll our own versioning within Buildertrend just because we haven't really needed it. Most of our stuff's internal. We've been able to manage it. But we are getting close where we're going to need that soon. And I've been told they're actually in development on it, so I'm hoping they'll have that out there. But like I said, all the other major platforms, I know for sure Kafka and like the Event Grid do support that filtering. That is by far the easiest model I've seen to support versioning within the eventing, because then it's very declarative. I know every message that published has specific versions, and my subscribers are going for a specific version, so I can even see what subscribers are still on old versions and who I need to bug to try to get to upgrade to newer versions before I deprecate that previous version. So hopefully that helps a little bit. I know there's some other patterns. The other patterns I've seen are all tied around, like I said, doing multiple topics and subscriptions, and that just gets really ugly really quick.
All right.
What's next, Brian?
I think we might have the audio fixed. The next question is, do you recommend having a central event bus, and have you seen issues with scaling?
Might want to repeat the question just in case we don't have it.
All right. What was it? Do I recommend a central event bus, or what was that? Can you repeat that one?
Do you recommend having a central event bus, and have you seen issues with scaling?
So 2 parts. Recommend a central event bus. I would say a lot of, like for our case, I haven't seen the need for it yet. If you have a lot of orchestrations or workflows, that's where they probably provide the most benefit. A lot of those tools have, even if it is just using Logic just having a tool to do that for you. I've done both a couple cases of the kind of that mediator pattern, some tools in the past. They worked out okay. Usually they're halfway there. But if you are doing a lot of back-end business processes and workflows, a lot of sense to find a tool that does it. And like I said, it could be something like a Logic app that is still very lightweight. But having something that you can have easy visibility into what those workflows are. Because if you do everything through that burger pattern and you have a bunch of workflows, you keep chaining on more and more workflows, trying to get a complete view is really difficult. You can usually through, like I mentioned, if you do that monitoring, like I mentioned, you can look at messages and see what those paths are. But as you start adding more conditional logic within those workflows, that gets really tricky. So I think if you have a lot of business processes that are back-end workflows, I think it probably makes more sense to use a more centralized event bus. If it's something like in our case, most of our stuff, we're just firing those events out to let people know, like to let other systems know about it and work with it. We haven't really had a strong need for it. We have a few cases that those orchestrations will make sense, but it's so low right now, we don't really see a strong use case for bringing on a full-blown ESB. Second one is scaling. That's the one thing, like I said, that these systems, and it's every one of them, Kafka included, these are all designed for ultra scale. And so the only scaling we run into is we've had a couple, it's really on our subscription side, on a couple of our processors that are dealing with third parties, where we have a third party that, I think one third party that only accepts like 20 concurrent messages or something like that. So we are restricted to only having 20 threads going for that processor. And so, like I said, for the most part, even those haven't been a huge issue. The only ones we run into are we have internal, like if we have a really expensive internal process where we want to throttle it. But again, the nice thing is this gives us the capability to do that. We have some sync processes, especially with, like, if you're familiar with this, we have some syncs that are pretty heavy-handed with our QuickBooks integrations. So we throttle those a little bit more heavily. So, but truly throughout the day, like worst case is we might back up a little bit, and then usually an hour later it catches up and it's good. So we have not had any issues on the scaling side. On the publishing side, all of these systems handle just the numbers. If you look it up, what they accept in is just insane. How many messages they can send through. Like I said, we're doing about 20. I think we're right at 25 million messages a month right now, and we're doing all of the processing is honestly on one Windows service right now. We haven't even had to scale out the Windows service side for our polling, so we're still doing mostly polling. We're going to scale that out just from a high availability. I think we've recently scaled it out from a high availability perspective, but we didn't even need to. So definitely have not, and like I said, the numbers we have are nothing compared to WhatsApp. So definitely, these are really geared, this whole event architecture is really geared towards massive scale. So unless you have, the biggest restrictions you'll probably run into will be on those subscription sides. If you have tight restrictions around a specific API or a specific third party that you're working with, that's where you might run into some issues where you have trouble scaling it. And really, it's going to be working to get rid of whatever throttle those systems have.
All right. One last question from Tom. We have, if we subscribe to an event, in what scenario would we need to unsubscribe from it? What design pattern should we consider to do the garbage collection?
All right, so first one, subscribing, unsubscribing. I think too, as you move forward, the versioning, it's like, I guess that would just be changing which attribute. The only ones we've run into are, like the activity feed was a good one. If you're talking about from like we have an activity feed we have in our mobile application, so we're capturing all sorts of events that potentially go into that. It was really, there was a couple type of events that were really noisy early on, so that's a case where from a subscription perspective it could drop off, unsubscribe from that subscription, and that can be typically that's just done in that processor code. You would just tell it, you can do it two ways. You can actually pause the subscription within, I think I know both Azure and GCP have it where I can go into the portal and just pause the subscription and stop having messages get pulled from it, or you can do it within when you republish your subscription, you can just take out or republish your processor, you can take out that specific subscription. When you talk about garbage collection, I'm not sure what you're referring to there. Just that's a very broad topic. So, like this,
I think he was kind of referring to any design patterns around unsubscribing so that you don't have a topic out there that you're receiving messages from but not doing anything with and generating memory.
If we're talking about garbage collection, I would imagine it has to do with the client, right? The
Probably.
Client that's subscribing to the topic.
Yeah, and again, that's another one that's very platform dependent. Like the way GCP handles it, if you have a subscription, I guess they have a couple ways. They have an auto deletion. If you have a subscription that doesn't pull any messages, it'll actually eventually just drop that subscription altogether. I'm trying to think. I'm trying to remember how the Azure Service Bus. I don't remember that one auto dropping subscriptions, but it might have. So it really is the nice thing. And if you have some monitoring around it, and I think if you're doing the cloud offerings, I can go into we have out of the box with Stackdriver, we just plugged in our service, all the pub sub topics and subscriptions we have. And so we can, at any point in time, we can go back in history and see all the throughput on them. So I guess if people stop pulling from subscriptions, it's pretty easy to tell that those subscriptions aren't used anymore and we can deprecate them out. Same on the topic side. If there's nothing getting published to the topic, it's extremely obvious. So I think long term, as you build out more and more, the nice thing about it is it's really simplistic to see what's actually in use. So if you want to go back and do cleanup from time to time, it's very simplistic to see that versus I remember trying to deprecate some APIs in the past before we had some tighter monitoring around them. And that was fairly painful because you knew it was getting called, but you didn't know who was calling it type of thing. I definitely have not run into any of those situations with any of the eventing models. There's enough out of the box monitoring within any of the platforms that's really simplistic to see if those things are actually in use. And like I said, if that goes back to the metadata, if the publishers are including the metadata there, it makes it even easier to track those down.
All right. Well, I think that's all we had for questions. Any final thoughts, Andy?
No, definitely appreciate you guys letting me come and babble on about event-driven stuff. I haven't done that for a few years, so it's fun getting back into it.
With us as we deal with some of the issues and being our guinea pig for doing these live streams.
Yeah, I think first try to live stream only having a couple audio cutouts. So that's not too bad at all. So
yeah,
I think we're in pretty good shape.
Let's see. Go back to this. No. So yeah, we'll continue to do this as long as I suppose the government requires us to, and we'll reconvene our regular meetings as soon as we can. But in the meantime, we will continue to meet, and we'll continue to engage with the community. I hope you guys will continue to interact with us on Slack. There's a pretty active community out there. It could always grow and be better, and I think each one of you can participate in that. So thanks to Andy for presenting for us. Thanks to Advantage Tech for sticking with us, even though the event got kind of messed up for us, but I think we managed. Yeah.
Worked out.
Thanks to all of you for joining us tonight. Again, if you need anything from the user group, you know where we are. You can get a hold of us via email, Slack, or LinkedIn, Twitter, whatever. We're watching them all. So thanks again, and we'll see you guys next time. Thanks. Bye.
All right. See you.